evening, everyone. Welcome to the WHIPgroup Tech Entrepreneur Meetup. Thanks for coming tonight. For those of you who haven't been here before, every month we try and bring in an interesting tech speaker from all kinds of industries to help facilitate the tech conversation in Stamford and Fairfield County. We have a great speaker tonight. Many of you already know Mark Strauss. Mark co-founded WaveAerospace from his co-working desk here in Stamford in 2014. He had an idea for a unique propulsion system that could drive a drone faster and more efficiently than any other aircraft in existence. Mark built the platform from the ground up. He created component parts on his laptop, prototyping parts on his 3D printer, and then sending designs out to be manufactured. We look forward to hearing from Mark about how he followed his passion and took advantage of the tools available to him to create something totally unique. So please join me in welcoming Mark Strauss.
Thank you so much. As with every project, what may have started in my kitchen has ended up with the help of so many other people. In particular, I want to just note my co-founder, Steve Beauville. Steve, you around somewhere in the audience?
I think
he's probably gonna get something to eat. But Steve has been a CAD guru and worked on the F-23, and couldn't have done a lot of the stuff without him. But indeed, this did start very early. And we're gonna split this into two different parts tonight. It's not a pitch, and it's also not an advertisement for our company. It's more of a recognition of a new renaissance, if you will, something that doesn't come about very often in the entrepreneurial cycle that goes around. Just like chefs were the rock stars of just a few years ago, entrepreneurs have become the rock stars of today. If only everybody who saw that knew what was really involved. So this is really what's really involved. I'm going to begin by sharing a little bit about what I went through to get to where we are with our current project. I want to thank WHIPgroup. I should say that we have engaged them as our intellectual property attorneys and have been not just proud but really delighted with their help so far in this ongoing project. So thank you for having this program. I think it's very useful, and it's something that will become, I think, more and more important, your work alongside us as we go forward. I actually bought this $30 drone from Amazon because my housemate had one and I was jealous of watching him fly it around the kitchen. And I noticed that it would run out of batteries really fast. And if any of you have played with drones, you'll know they run out of batteries really fast. And that's disappointing. It turns out, if you can believe it, that they take a battery about 1/8 the size of a AA battery. Okay, now you've replaced AA batteries in your TV remotes and things like that. This small drone takes a battery about 1/8 the size of that battery and uses all of its energy in a few minutes. Now think about how often you replace the batteries in your TV remote. So the battery, as boring as that may seem, was one of the most unique elements of this little device. We can all imagine computers flying all kinds of things around the room. I usually equate this to a flying potato. I mentioned to someone else in the other room that drones are basically these days flying potatoes. But one unique part of them is that they're able to eat up all the juice in a battery in just minutes, where it would take often months to get that much energy out of a single battery. So like any good entrepreneur, I sat around watching cartoons and doodling on the end of envelopes. You'll see I actually put a date on the top of all my doodles. That's residual effect from my very formal education as a chemist. I was always told to put my date and the name, and 2 days later I was at the office working on this which is also dated. And it was funny because there's a gentleman here, I think, that gave me the call, Peter Prop. Peter, are you here? There he is in the back. I got a call from Peter. Peter, I think it was you. It was the next day, and I got this call from the co-working space where I was. It was kind of a strange call. He says, Mark, we need the whiteboard. And we're looking at it, and we're really not quite sure what's going on with this and whether we can erase it. And in fact, these were the original calculations that I was doing, just one more step in the back of the envelope, to see if it was possible to take that energy from the battery and have the drone stay in the air twice as long. Not really sexy a problem, but a problem nonetheless. And boy, I thought, wouldn't it be fun if we could just keep these things in the air twice as long? So I started looking into batteries, and I went on Amazon and looked up batteries, and I was faced with this. Now, the amazing thing about this, let's see if I can, is this wired? Can I pull this out? Yep. The amazing thing about this picture is that it's available on Amazon. In other words, some large number of people in the United States are seeking this product. Now I can imagine another tinkerer, electrical engineer, putting this together, right? Wouldn't it be convenient if I could plug in one plug and have the power come out with the socket that I need? This is a drone adapter. In other words, the drone ecosystem was so broken and so many people were involved with it that this is the first thing that came up when I went into charging a drone on Amazon. Now again, think about it. Amazon does not carry things that you sell 3 of, right? That's how Amazon works, by selling lots. So there's lots of need for something like this, and I immediately realized that the battery space, as boring as it may be, was something that we could play with, and there was some opportunity there. But the real mystery was, what if we take this $30 drone from Amazon and we start changing the environment in which the computer can fly? Now I'm saying that the way I would say it to an engineering class. But changing the environment in which something flies is a non-trivial act. It's like bringing your machine to the moon, or bringing your machine to Mars, right? The gravity, the density of the air, everything about it needs to be changed. Today we live in a very special world. In fact, this probably could have been done a while ago, but in fact, the first step, and I'm walking you through these first steps pretty carefully, one at a time, so you can see as it accelerated closer and closer to the insanity we're in now. So, next picture is that same drone attached to a garbage bag in my kitchen. That garbage bag is filled with helium. Now, most of you have probably seen helium in a balloon, but did you know that if you put it in the garbage bag and hold the garbage bag upside down, it doesn't spill out? And the question here was, if we take gravity away, what will happen? This garbage bag held up almost all of the weight of that drone. That drone, as far as the computer's concerned, inside, and I didn't modify it, I don't know how to do that, okay, thought that it weighed about 1 gram. And to my amazement, the computer didn't care at all. It simply slowed the propellers down to the point where it flew normally. Keep in mind, 95% or more of the weight of that drone is being held up by the helium in that garbage bag. Of course, we later let the garbage bag go outside and pretended it was a UFO. So if you heard anything on that day, okay, that's that same drone. Amazingly stable. Well, this was a revelation. A revelation that the most sophisticated drone computers that were out there, which by the way, have inertial measurement units that are far in excess of the complexity of the one in the lunar module that landed on the moon don't really care how much this thing weighs. In fact, they just want to keep that device stable. So of course, down the slippery slope we go as we accelerate through the stars. Now we have bigger balloons. I could only get happy birthday balloons, which completely stymied the neighbors. The neighbors now have no idea what is going on in our backyard. However, look at the stability of that drone. With 95% of its weight taken away. What this meant is we were free to take the weight away from that drone in any way we wanted, right? Figured there must be a better way to lift things. Well, in fact, I knew there was a better way because anybody who's flown on an airplane knows there's a lot better way to lift things. Otherwise, we'd all be flying drones right now, right? So the next step was to build a bigger drone. And here we go. This drone eventually became this drone. You're looking at a GPS lock. You can actually see the battery on top. And that antenna sticking off way high is a GPS antenna. So you see that flying right there. Looks like we lost a little bit of audio sync there. And that's funny.
Just picture angry bees.
Just picture angry bees, right? And you have to understand that I'm not taking pictures or anything, so all the neighbors are seeing are hours and hours and hours of these drones hovering in the backyard making this buzzing sound. But at this point, we're faced with a problem. My ideas were beyond what I could build. And that's what sort of brings us here today. And I was so excited to come into this office a few months ago and see the 3D printer in the back, that there are technologies that have come along that have changed the way we build things. I can remember putting glue on 2 pieces of balsa wood, we were talking about this earlier, and having to wait for the glue to dry. And then we got super glue, right, that you could put together and spray it and it would dry almost instantly. That was a revelation. Now we can only imagine a part and suddenly it can be made. And the next video I want to show you is a video that I found of a young woman well, it's hard to explain, but just sharing a little bit about how she thinks about what she can do right at her desk right now. Well, I guess first I'm going to show this. This is one of our 3D printers. So, oops, I guess this video's not going to show. You can see it printing here. And I don't know why it's not going. Oops, I seem to be out of sync with our printers. But we'll skip right to here. We'll come back to that video. Sorry about that. What I want to jump to, though, is the idea that what we thought about after that first video you saw, this last video you saw, is what would be the most efficient way to hold up an aircraft. And again, just thinking about it, what's the most efficient way we push an aircraft forward? It's a jet, right? It's a jet engine on the bottom of a jumbo jet. I'm assuming that's the most efficient, because it seems to be the decision that everybody makes to push their jet forward. So our thought was, what if we put a jet straight down in the drone? And in fact, this drone, when you come up afterwards, has a jet engine sitting right down the center. That jet engine can lift this drone, but it cannot control it. But it can lift it very efficiently. So what I'd like to do is show you the first flight of this drone, earlier version of it, flying. And again, one more revelation that there were opportunities here. these aircraft evolved to include other unique lift generating and force generating attributes. Like here's one with a wing, and so you'll see it's flying on its wings. Oops, again, I'm not getting the videos, but you can see it there. Here you can see it flying on its wings. Those are helicopter blades right there. And then this is the first version of the wing drone you see in the other room. This is its first hover flight, right there. That flight was 36 minutes in the air. For those of you who know drones, know that 36 minutes is an eternity. In fact, it was even amazing to us. This was its first flight, and at the end of its first flight, it actually decided to land itself. It was programmed to land at 30% battery left, so it actually went 36 minutes and then decided to land. It could have stayed in the air far longer. Okay. This is the same drone you're looking at in the other room. This has been century built. Again, the tools we have are incredible and they're available to everyone. Even the propellers and the simulations we do are all available on the computer right now. I think the software to do this is less than $300 total. And we're able to run these propellers through basically what we'd only be able to use a wind tunnel for. So this is an amazing thing. Not only can we continue to have the ideas that we've probably been having throughout history, but I think it's been about 10 years since the last big project I've built. 2 years ago I sold a full-size airplane, which was my last project, and it took about 5 years to build before that. And I didn't think I would build anything for a long time because things actually got expensive, or they got either too expensive to do or too involved, or I had to stop my job to be able to do it. But what I've realized is the ability to build these small aircraft and have unique tools to test these things is something that is unique to this time in history. It's really amazing, and it's a time that hasn't been here, I think, for quite a while. In fact, I would argue since the last Renaissance. Now I want to tell you a little bit about why this impacts more than just us. Okay, Stamford is a very, very unique place. This is an air shot from Google Earth that has the airspace overlapped from New York and the other major airports around our area. I don't know if you can identify all the different spots on it, but if I look across here, what we'll see is this is Greenwich Point right here, and this is Stamford with its 2 canals. This is Huntington Harbor. Stamford is the first town in Connecticut, the first city in Connecticut that is outside the New York Class B airspace. So this airspace, which I'm not going to go into now, if you fly up high enough, you're going to pierce it. And right now, the FAA isn't quite sure what to do with that. We know that in England, when drones or other aircraft that are unknown have pierced aircraft airspace, they've shut down operations. Not a good thing for New York. But Stamford is the first city in Connecticut where that airspace is free. And Huntington is as well. And what we'd like to do is create a commercial drone zone, basically a commercial interstate across Long Island Sound. One of the biggest problems left in the creation and the innovation of aircraft is the ability to test them safely. And there's a lot of work going on in this. Rome, New York is busily working with FAA and Boeing to try to create a way that they can use radar to pick up drones and integrate them into the airspace with aircraft, with people. But the truth is, that's going to take some time. But drones are now ready and maturing to be able to be commercialized right now. And that takes practice, and it takes failure, and it takes successes that need to be repeatable. And this is one of the projects that we're working on alongside the FAA. So when we talk about the drones that we're creating now, we're talking about drones that not only stay in the air long enough, but stay in the air long enough to either carry something a long distance or carry something heavy a very, very short distance. This corridor would be very similar to the corridor that is right down the Hudson. For those of you who are pilots or maybe have had the opportunity to fly down the Hudson corridor, the Hudson corridor has an uncontrolled airspace. So you can actually take a small plane and fly it down the Hudson underneath the New York air traffic. And it's actually a beautiful flight. There have been incidents down that corridor, and you have to be very careful because you can imagine it's very busy. But our proposal is to create an airspace corridor with the FAA from 500 feet to 1,100 feet, 1,000 feet wide, that would have a multi-year waiver from the FAA. So under certain conditions, any company would be able to basically test drone traffic across this space, and commercial aviation would avoid it. So not only have drones evolved to the point where we need this type of thing, we have to also evolve our airspace so that we can deal with it. In terms of our need for air traffic or vehicle traffic, we see it right here. Right now you see this is actually vehicle traffic on the roads. But I don't need to make an argument, I don't think, given the news over the past couple of months about the infrastructure in New York, to argue much that we're going to need to use the air. And actually the air is underused. And in an electric-based ecosystem, we actually take away a lot of the car pollution that would be generated. And you can see here, one of the things you will see here are cars and taxis and heavy goods and vehicles. The brown and light commercial vehicles, the blue, the light blue. That's right above the biggest section. So heavy goods and vehicles, those are very heavy. Yes, question?
What kind of percentage of the traffic could you actually take away with a car?
Well, that's a good question, right? So if you look at this right away, you see that cars and taxis are actually this big section on the bottom, right? But the next bigger is light commercial vehicles, right? And that's what drones historically have not been able to replace. If you read articles about the delivery for CVS or delivery for Amazon, you hear articles about the delivery of 2 kilogram or less. Zipline in Africa has been delivering 1 or 2 liters of blood at a time. Don't get me wrong, great uses for drones, but not great uses for impacting this chart. What we're suggesting is that the new technology that we're working on, and that we hope other people will now join in, is a drone or electric autonomous air vehicles that are capable of carrying commercial viable weights. So in the case of the drone in the other room, just as is, you're looking at about a 30-pound payload, with the turbine about a 50-pound payload, and with the gas version, not gasoline, but with Jet A, which is a hybrid electric Jet A, it's able to carry about 100 kilograms, which meets the need of light commercial vehicles, so the second biggest here. Now there's no question this doesn't necessarily solve the car issue, right? And there's been suggestions to build tunnels and bridges and things like that. I don't have a resolution to that, but we can start attacking that second highest area that up until now has been pretty much ignored by the space. So just to end today, and I appreciate your time, the main points I want to make are, first, all of this is within reach of anybody who's interested. We've taken very few resources out of pocket. Yes, we have committed time and we've committed tens of thousands of dollars, but we haven't had to mortgage our houses again and again, like I have in the past with some of these projects. But we have been able to produce something, not just an idea, but something we have hundreds of hours of flight time on to show that these ideas work. And we've been able to do it with tools, isn't that? We've been able to do it with tools that in many cases are sub $1,000, and we continue to work. The most expensive things you'll see in the other room are actually the elements of that drone, such as the turbines and things that go into it. This is the drone in the other room, some of you have asked, with the turbine in the middle. Some of you have asked what it would look like, and I just wanted to give you a picture of that and what's coming along next, and hopefully maybe in 12 months from now I'll be able to come back here and share what's coming next, and that is our X6, which is the world's fastest, heaviest lift drone, capable of taking off in 70, 80 knot winds, circumnavigating, inspecting a ship at sea, and landing to a precision of less than a centimeter, again in a 70 knot headwind, autonomously and every day off the top of the ship. So this is some of what we're working on now. Again, bootstrapped in the true sense of the word, but in a new way, we're able to bootstrap an aircraft. And having built an aircraft and having learned to fly before I learned to drive, I can tell you it took a month of babysitting for one lesson. Today, it still takes a little bit of creative financing, but we are able to take the tools at hand and build things that were just 20 years ago price inhibitive and unthinkable. So thank you very much, and I'll be happy to take your questions.
First, thank you. It was informative.
Thank you.
I don't think it's like. Just curious. In order to get those speeds, you're not going to be able to fly on the drone as it took off vertically. You're going to have to tilt it a bit. So how in turn would you propose to stabilize the load?
That's a great question. So the question is, as the drone rotates to fly fast, its primary source of thrust is that center engine. In this case, you see a Jet A powered turbine, which isn't much larger than the one in the other room. Jet A, by the way, is kerosene and much safer than gasoline, which is why jets use it. So I want to emphasize here that we're not flying around with tanks of gasoline, which is flying around something safer. Great question, however. The answer to your question is, it's those outer engines that maintain its orientation at all times. So this plane has no control surfaces on it, but instead uses the speed of those outer motors on the tips of the wings to control its position. It would be very similar to the fins on the end of a missile or something like that, except here we're spinning a very high-speed propeller. In fact, that propeller you saw in the animation was a very high-speed propeller that we use. The reason others can't do this, and the reason it's so unique to us, is because that center engine allows us to gives us the opportunity to modify the shape of those outer propellers, and that's something that is protected and unique to our design. This is considered a 6-axis control system. In other words, if you think of a plane, it can go up and down, it can go side to side, it can turn side to side, it can tilt side to side, but it can't move side to side. This can actually do all of them in flight. Yes?
So I think you just touched upon this, but going back to the beginning of your talk, I'm not sure I was able to connect the dots. So the key insight you had is that you don't need the 4 propellers for lift and stability. If you could get lift some other way, you could use those just for stability. Is that the key insight?
You actually are correct that I skipped one little special little piece. The key is that those outer propellers aren't efficient in doing both lifting and stability. So from that, the first question we addressed is, what if we take away the lift component? Can it still fly? The driving idea behind all of the intellectual property here is that by letting each system do what it does most efficiently and taking away those things they do not do efficiently, we get a huge boost in total efficiency. So what we learned was that those outer motors, when they're spinning near max to lift a drone, they're actually, when they're right near their maximum, are not very efficient. They want to spin somewhere in the middle, sort of like cruise on your car. They say driving at 55 is more efficient than driving at 95. Well, that's true, right? But those motors, in order to keep everything in control and lift, were spinning at 95% of their ability. So what we were proving was that we could remove the lifting the requirement to lift, and the computer would still maintain stability. Then it was up to us to find a replacement.
So then you could optimize the shape of the four propellers for control of the plane.
Not just the shape, but their speed, their distance from the center, everything about them. That's exactly correct. Does that make sense?
Yeah.
Yes.
Mark, if one of those propellers on the end failed for whatever reason, is it programmed so that the other three can adequately compensate?
Right, okay, so this is a great question, and redundancy is the center of the question. The reason we have hexacopters and octocopters, right, with 6 propellers or 8 propellers around the center, or sometimes they have a propeller on top and a propeller on the bottom, you see, is this redundancy issue. So on a 747, calculate the chance of losing control of the aircraft. You actually have to lose just about all 4 of the engines that lose control of the aircraft. In a regular quadcopter, you only have to lose 1 of those. Now, as far as the wings go, as far as that center engine goes, we have redundancy built into the system. We also are using highly capable and high redundancy engines. But what you're seeing now requires those 4 engines to be running. We have multiple systems on the drawing board for addressing that. I should note, however, that should this thing fail catastrophically, and we have had failures catastrophically, structural failures during testing, that the whole system and the fail-safe system is very specific here. Not only do we carry a black box at all times so we can track the problems with it, but the drone is designed to go through a whole series of things to keep itself as safe as possible, as well as people on the ground as safe as possible, including parachute that will come out, that's an isolated system, and even we go so far as in this case where we have a turbine that's burning Jet A. The second there's a control problem, that Jet A turbine turns off and a clutched electric motor engages to cool it before it hits the ground. So I just want to emphasize that these are addressed. We are working on some new things that I can't really discuss now that actually bring redundancy to the outer propellers without reducing efficiency. And one of the problems is over-under propellers, and this is from NASA, not from us. Over-under propellers are simply not efficient. That's why you don't see them on Amazon's proposed drones. That's why you don't see them on many others. And so as efficiency goes, we want to try to stay away from that. It's the same reason you don't see 4 engines on a 787 any longer. You see only 2. That's actually less redundant. However, it's much, much more efficient, and they've done other things to build in that redundancy. Question?
Yeah, I just had a question about the corridor between New York and Stamford.
Yes.
So that would be like a testing corridor maybe
for either. We wouldn't specify why you were using it, but there would be requirements for using it. So there would be additional requirements above and beyond a Part 107 license, which is a commercial license. There would also be requirements for flotation on the drone, for a black box on the drone, for redundancy in the flight system. We expect to lose some over the sound. However, we would be flying within the same regulations of uncontrolled space that full-size aircraft have. So this would not require any legislative changes from the FAA. It would require what's called a waiver. And the waiver, what sets it apart from other waivers which can be requested, is that the waiver, similar to a single waiver that was recently granted out west, would be a 1 to 2 to even 4 year long waiver. So it's basically an extended permission to fly outside certain rules that have been set up. We would be flying above the consumer drone space and below any controlled commercial aircraft space, and it would be indicated on a sectional. So it would be very similar to if you were flying and control called and said, Burlington 273, just be advised there's glider traffic in the area coming into Burlington. Something like that, where there's aircraft that are uncontrolled in the area. But in general, we would be outside the flight paths of any commercial traffic.
How low do the planes come into Westchester?
Well, Westchester flight, the Westchester pattern is actually 1,200 feet. So we're 100 feet below that. They actually fly what's called a sound visual approach. Actually, I learned to fly at Westchester. Once in a while they come in there, but basically they would be aware of that. They would be flying above that. And again, we would be flying at a 90-degree angle to that approach. No doubt there will be lots of questions to answer. The idea here is that instead of getting 20 different waivers, the FAA would be dealing with a single waiver with known requirements, known timing. You would actually schedule a flight time like a flight plan so that the FAA can track it. Where we come in is we would do the tracking. So this isn't a business per se, but it does generate revenue, and then all that data would be made available, perhaps in a unique blockchain type ledger to the FAA. But again, we hope that that will actually serve them as much as it serves everybody else. All the flight in both Huntington and Stamford would be 100% over water. So we would use the canals on both sides for both the landing spots. So we would not be flying over homes or over people at first, which by the way, the FAA has waived that as well. We wouldn't be seeking that type of waiver, but trying to bring some order to the ability to commercialize the drone space before it is integrated fully with the passenger space, which I foresee taking much longer than. One last question.
Yeah, we got time.
Okay. Then.
I'm just wondering if you would describe more detail about how a jet works. I mean, where in there is the combustion happening? And
Sure.
I know air goes down to the top.
Absolutely. So if you can imagine, a jet is basically a tube. And it has in the most basic sense, it has a single axle that spins in the middle. When you start up a jet, you actually spin either with air or electrically with a motor, that spindle in the middle. And the first fan in that engine blows air into that tube. Okay? That's beginning is called the compression stage. And when made efficiently, the air not only gets pushed down there, but it actually gets compressed slightly. So in other words, we fit more air into the tube than would normally be able to fit. That's a good thing because it means we have more oxygen than would normally be able to fit, and therefore we can burn more fuel than would normally be able to burn in that little tiny area. About halfway through, we introduce a spray of fuel into the air and we ignite it. We ignite it with something called an igniter. right? And that expands as it heats up, and it goes through the second fan. So the second fan now has an expanding air blowing through it, and it spins because that air is expanding through that second fan. And that second fan, which is hot, that's the hot end, right? It has that same spindle going all the way through, which then self-sustains the compressor end if you do everything right. It actually turns out it's a little tricky, but that's basically all a jet is. And one of the reasons it's so reliable and why people love to use it on big airplanes is because although modern airplanes do have a few more moving parts than just one, in essence, it's simply two big fans hooked together by an axle, right? The catch is one end is very, very hot, right?
So it's the expelled air that's hot that pushes the boat.
The expelled air is hot and expands, right? And so it's not the air that's pushing it forward, but the mass of that air coming out, right, is equal and opposite reaction according to Newton. It pushes the aircraft forward. The reason jets don't work in space is solely because they have no oxygen to bring in the front end. If you feed oxygen in there are hybrid engines now. But that's the basic. The beauty is, some of you have heard of a ramjet. I'm gonna get way off topic just for 30 seconds here because it's so cool. In a ramjet, okay, there's no compressor in it, okay? So as the air goes in the front, the front narrows and the air naturally compresses into the front of that jet engine. You don't even have to have that fan in the middle, okay? And then it burns on the way out. Wow, talk about simple. The catch is it only works when you're going faster than like Mach 3, yeah. So it's, but maybe one day we'll get there. Any other questions? Yes.
Are you looking to possibly expand areas that, like if you do this successfully, Connecticut, New York, Connecticut, to go to other areas?
Absolutely. I mean, we're a very young company. These are the first commercial version of our aircraft is sitting in the other room. It's just about to begin its second round of flight testing. Its first one ended not so well, but that's to be expected. It ended, I should say, not so well in terms of the aircraft, but 100% safely in terms of everything else, which is thumbs up.
No video, it didn't happen.
What?
No video, it
No. Right, the black box says it did. However, the short answer is yes, we'd love to see this. Really what we're about, though, is very simple. Is right now, and even when you go to investors, and this is not an investor pitch or pitch in any way, but even when you go to investors, the second you say drone, what they think about is 2 kilograms going about 20 miles in good weather. Okay? We can fly 100 kilograms or 50 kilograms in the worst weather you have ever seen, right? And we can bring this out to Montauk and back, or if a boat's sinking, we can get there before the Seahawk. So before the boat sinks and the people's body temperature who are in the water fall below the ability for infrared to find them, we are there. We can mark the water, we can drop a radio beacon, and we can, whatever, a raft, we can get out of there, and then the Seahawk and the guys and gals who are trained to do the rescue head out. And that's what we do that no one can do. Because the nature of a drone up until now is that it's limited in the air. The type of weather it can respond to. There's a reason you don't fly helicopters to LA. The reason is it doesn't matter how big the helicopter is. It doesn't work. Helicopters don't go 500 miles an hour. They are physically limited by their design. What I would say is the magical part of this project has been what started as doubling the battery length and has ended as, and I can say this and I'm proud, I've developed 800 products in my lifetime, only maybe 3 I've discovered to be truly new.
thank you all for coming. Couple quick announcements. In December, we're going to take a slight break from a tech presentation, but we're going to have a holiday party. So come back on December 17th. Should be a great time. Also, I try and include this. If you could leave your name tags in the basket before you head out. And also, there was a set of car keys that was left near the front, and I'm told the security office downstairs has that, so you can pick it up on your way out. So thank you again, Mark. And oh, I'm sorry. And Brenda's TechCell Stamford is having an expert on term sheets on November 20th at what time?
6:30.
6:30. Okay. All right. So come check that out, and thanks a lot for coming tonight. Thank you all.
Thank you.